Okay, let's go then. Thank you. So, ladies and gentlemen, welcome on board the round table on ride and handling, hosted by our friends at VI Grade, of course. My name is Marco Gadola. I'm from the University of Brescia in Italy, as you can probably see behind me. Here at the university, we run a compact simulator from VI Grade. And I can tell you there are great expectations for this session. We have an outstanding panel of guests, as you can read once again just behind me. And we have people from key players in the automotive world, like tire manufacturers, testing facilities like IDIADA and MIRA. And of course, we have people from vehicle manufacturers. Our focus will be on the vehicle development process in terms of ride and handling behavior of the vehicle. And of course, we'll speak about what role the simulators can play within this process. And unfortunately, I have to say that Carl Sanderberg from Volvo had to withdraw just half an hour ago. And okay, that's a pity, but I think we can start right now. And I'd like to start off by talking about tires. We have Alfredo Corollaro from Bridgestone and Massimo Mangia from Pirelli here with us. Alfredo is actually representing Bridgestone, where he's in charge of tire and vehicle modeling and also driver in the loop activities. He's based in Italy in the R&D facility, which is close to Rome. Massimo represents Pirelli. He's in charge of modeling and he's based in the Pirelli headquarters in the heart of Milan. Actually, Alfredo and Massimo, I have a question for both of you at the same time. Of course, at Bridgestone and Pirelli, you can deploy all the state-of-the-art tools like flat track testing machines for tire testing. You have dedicated proving grounds. You have a lot of, let's say, brain power in your R&D departments. At Bridgestone, there is also this unique track for tire characterization outdoor. But we all know very well that tire modeling is an extremely complex task. And the question is, can a driving simulator help to, let's say, close the circle and finally achieve what we call virtual tire development? And I'd like to start with Alfredo. Hi, Alfredo.
Yeah, hi Marco, thank you. Yeah, well, as you said, the tire modeling is a very complex task. At Bridgestone, we are really moving forward with the virtual development. For several years, we provided the engineers responsible for tire development with all the tools to design tires fully virtually. So until a few years ago, the virtual testing was based on tire standalone. For example, we have developed a methodology to virtually replicate our test rigs with a very good correlation so that we are capable to provide the OEMs with the semi-empirical and physical models such as MF tire, Swift, F tire, and CD tire of not yet existing tires. On the other side, the assessment was based on offline vehicle simulations with all their limits. By performing open loop maneuvers involves in assessing the different specs basing on objective metrics. And then the correlation with the subjective assessment is a very challenging phase and you hardly reach the full result to take the full picture of the performance. So from this point of view, of course, the driver in the loop has represented the final piece for a full virtualization of the design process. For a few years, we are gaining experience to use the driving simulator for tire development, also leveraging the expertise of some of our customers with whom we established a very fruitful collaboration. For example, we have been selected as the unique tire supplier for the brand new Maserati MC20. And I'm so glad that Giuseppe Raimondi is here with us today. Well, during the development, we leveraged on their incredible expertise, using their driving simulator extensively during the development of the tires for the MC20. That has been from the concept to near the final industrialization in a fully virtual environment. So we had the chance to subjectively assess several tire specifications with a flexibility that the physical testing does not allow, of course. And the subjective assessment of on the physical vehicle has been done only at the final stage with a very good correlation, by the way. And this gave us the opportunity to complete the development of the tires in just 18 months. So thanks to that collaboration, we gained a lot of experience on how to properly use the driving simulator for tire development specifically. And so we established further collaborations with the several OEMs, working together to insert the driver into the loop, even when it was the first time for some of them. So what I can say is that the driving simulator is a very powerful tool, but you have to learn how to use it properly to take the maximum advantage from it, and above all, to secure the correlation with the experimental test, at least in case of tire manufacturer. I mean, while in case of OEMs, as we are seeing also in these 2 days, the driving simulator can be used for several purposes, not only for vehicle dynamics, I guess for implementing new control logics, to develop ADAS, to check the HMI, now even with the passenger in the loop, to monitor the autonomous driving, talking of driver over the loop. As I recall, this approach was named at the beginning. Well, in case of tire manufacturer, I see just one purpose: the tire assessment. That does not limit to check if a tire is better than a control or not. But our drivers usually evaluate the tire in several items with the very specific maneuvers that sometimes cannot be even reproduced properly on a driving simulator, due to the limits of the tire models, for example. So we had to identify some workarounds to analyze those items anyway. And so from this point of view, I can say that the driver must be trained about what he can feel, what not, what can be evaluated and what not. And it's so it's a huge and continuous work that we are doing little by little in Bridgestone, let's say. But in the end, I can say that thanks to this several experience, the driver in the loop is now becoming a reality in the development loops in Bridgestone. Of course, on the other side, so far we are using the driving simulator for handling assessment only. Well, it's not enough for a tire manufacturer, at least. And I think that Massimo probably does agree with me about that.
Yes, thank you, Alfredo. Yes, I agree. I will probably try to discuss a little bit on the second performance of this roundtable, that is the ride. The virtual ride development is probably a step behind the handling, but we see increase of activities in this area and a lot of opportunities for the future. If we think the vehicle of the future, that is autonomous vehicle, we can imagine that the ride performance can be a first order respect to handling. But currently, in handling, we can see that as tire maker, we can close the loop tire and vehicle, while on the ride, we can focus mainly on tire standalone. The reason is that we do not have availability of vehicle ride models. So we typically generate ride models and share with the car maker, and they can make some assessment internally. We use commercial models, but also models developed internally in Pirelli that can be generated by finite element, so to have completely virtual loop. Typically, we validate with click test or checking the load variation when the tire is rolling on a replica drum. But during tire development, we cannot focus only on dry handling and ride. So there are a lot of other performances that we should consider. And if I need to think of the key hot performances of these days, I will probably start from the market trend, where we see a lot of new electric vehicles. And as a consequence, there is attention to the overall rolling loss in real driving condition that are associated with the battery life, but also noise and also tire wear due to the increased torque at the wheels. And also, if we consider the global market, the robustness is also an important factor due to the different road condition, but also driving attitudes in the various regions. I would like also to close my speech with a kind of wish list of what would be nice to see in virtual world in the next months, years. So first of all, it would be nice to improve the way to exchange the vehicle models. Car makers are using a variety of software, and the translation from one environment to another is not always straightforward. Moreover, as also Alfredo was anticipating, vehicles are getting more complex with a lot of active systems, suspension, steering, aero devices, torque vectoring. So it would be really very useful to find a smart way to include this functionality in the shareable models. Of course, we need to guarantee that we can protect the intellectual properties of the various parties, but also it would be nice that not only the car maker, but also all the supplier can have vehicle models as close as possible to the vehicles that we can test on track. And as I was mentioning before, the possibility to share a ride-friendly vehicle model would be also great. Then we work with a lot of car makers, and we see that the number of car makers is constantly increasing. We all see a lot of new startups, and of course, each of them has a preferred track where to test. So it's very inefficient to buy and rent all virtual proving grounds. So again, it would be very useful to maybe to have a system like pay-per-use, where we can access a specific track for some numbers of days, as it happens in the real world. And this would be very useful, I think, for the many tire makers that are investing in driving a simulator. As Pirelli, we have installed our static VI grade driving simulator approximately 1 year ago. And so that's all from my side. Thank you, Marco.
Okay, Alfredo and Massimo, thanks a lot. Just a very quick question about your wish list, Massimo. The first thing that you said, do you mean that it could be very nice to have a standard, some sort of a standardized vehicle model, which is something similar to a Passaica magic formula transferred into the vehicle sector?
This could be one possibility. The other one could be that all the main players can agree on a really standard measurement or standard numbers that can be easily generated, so that we can really move from one environment to another in a seamless way, so without the doubts that maybe some data are not consistent.
Okay.
Yeah, Marco, if I can add something about this, yeah, this is yes. True. I mean, I fully agree with Massimo. Of course, at least in Bridgestone, we used to be provided with the vehicle model for offline simulation, or even for the driver in the loop approach, directly by the OEMs, let me say, especially in case we are talking about a vehicle that is not yet existing, a prototype, and this in the, in the framework of the full virtualization of the whole process, not only from a tire point of view, but also from a vehicle point of view. This is an important step to be, to have the possibility to exchange vehicle models, even in case they are not yet existing. Well, from this point of view, I fully agree with Massimo that the way we exchange models, it's very important. For example, in our case, we are establishing methodology, a new methodology, let me say, in collaboration with some strategical customers to make this process as simple as possible. So yeah, I fully agree with Massimo. This is an important point for us.
I think this is a very innovative idea. People at VI Grade should think about it. And also we have a question for Alfredo in the chat, I believe. Maybe you can answer very quickly. Could you comment what tire model did you use for the Maserati MC20? Just very quickly, Alfredo.
Yeah, it's very simple, because it was MF tire. All the development has been made using MF tire.
Okay, excellent. Thank you. And I think we'll leave other questions for the end of the session, if we've got time, because I would like to go on, and I would like to ask something. Richard, are you here? Richard Hill?
Yes, I'm here.
Yes, thank you for being here, Richard. Richard is Chief Engineer for Vehicle Dynamics at HORIBA MIRA, which is a very impressive engineering and testing facility based in the UK. I'm sure you all know it. And Richard, I believe that MIRA has really been a pioneer in integrating advanced simulation techniques with traditional testing based on proving grounds and on physical prototypes. I have two questions for you. The first one is, can you describe the role of the simulator within the process of vehicle attribute development at MIRA? And the second one is, how does this zero prototype vision appear to you in perspective?
Thanks for the question. In MIRA's attribute-driven vehicle development process, the driver experience has always been the primary consideration. So you can imagine the simulators are a major enabler for us. This starts with the benchmarking and target setting process, in fact. So whilst the initial high-level marketing positioning benchmarking is still done in the real world, we can actually transfer the target setting into the virtual world. To enable us to do that, what we do is actually create virtual versions of a number of the benchmark vehicles that are used for the marketing positioning. We do this using our KNC rigs, damper rig, wind tunnel, etc., in conjunction with a series of objective tests. And this gives us a critical reference for the program. Plus, it also gives us a correlation with the real world, with the virtual. The targets are then actually set using a high-level parametric model, which we evaluate and modify to subjectively, on the simulator, achieve the relative performance against the benchmark vehicles. So what that means is that you're establishing a relationship in the virtual world with it that should translate across to the real world, and you can then have much more confidence what you're doing. The use of those benchmark vehicles really does improve your confidence, but it also, as a key feature, it allows participation of sort of client engineers who haven't necessarily had a lot of simulator experience to actually drive the virtual benchmark vehicles, go outside, drive the real vehicles, and understand that relationship. So when they come to try and judge the performance of the proposed vehicle, the targets, they have a much better understanding of what that means real world. It's not quite the same as we know, but there is that relationship, and you actually get that correlation. So that's the key first step. Once we go into the target cascading from that, having established that high level target, we can do that in our normal way as a starting point, but we can then refine those targets again as we go through, moving from the high level parametric model into models based on multi-body and based on the design as it evolves, with all the other considerations coming in. All that time, throughout that process, you keep on checking back to the simulator to understand what that means to the end user experience, to the driver experience, because that's your key decision, that's your key information. Where that really comes in, of course, is you always have to make some attribute trade-offs between the different parameters, cost or whatever, to actually have what it really means to the customer, rather than this gut feel of I've missed the objective target by 0.003. You can actually put the customer in the vehicle, put the engineers, the client in the vehicle, and say, okay, this is what it means. If you don't achieve this, this is the difference in how the vehicle will feel. So you get much better decisions based on the program and much better trades. The ability to evaluate post-changes in the design on the simulator referred back to those benchmark vehicles, and then to be able to compare to the benchmark. And when you're not quite sure, the ability to, even later on in that program, to go out and drive the real vehicle to understand, okay, it feels in simply it's going to be just a little bit worse than benchmark vehicle A. What's benchmark vehicle A really feel like in that particular move or a particular surface, what have you? Again, even in real world development, you can get locked into a particular problem on your test track, a particular corner, a particular surface, and you then go out and drive a broader drive, and you find out in the real world that's not significant, or you find out yes it is. You can do that because the danger is in the virtual world. You can do the same thing. You probably have not as great a variety of tracks to drive on. You can find out on the model you have a real problem. Do your correlation, does your benchmark vehicle have that problem on the track? Go out to real world, does it have in the real world? If it's not in the real world, it's probably not a significant problem. So it's continue this relationship between understanding what it means in real world, what's it mean in virtual. So we tend to continue to use these virtual benchmark vehicles right through the program, given a consistent reference. And to be honest, actually, that's something that you quite often don't get in a real reference vehicle, because over the 2 years of the program, that vehicle may well have degraded somewhat and changed its characteristics to some extent. That itself is a risk for the process I'm describing, because it means in actual fact, when you do your correlation between the real world has changed that little bit. So you do still have to be careful of that. So very quickly, obviously we use the simulator right through all the phases, from the benchmarking, the supporting the cascading, driving that virtual development phase, supporting the physical development by using it as a screening process to select what tests, where we should focus on the limited prototypes available, and minimizing the amount of development parts we require, right through to doing effectively a parallel sign-off at the end between the virtual vehicle, which is your theoretical ideal, and your prototype, which is probably built with a number of imperfections anyway, although known. You can actually sign off on both those. So that's effectively the process we're following. Finally, just with regard to your second question, the achieving the zero prototype program delivery, we're making great steps in that way, but that final step is a very difficult one, and question whether it will be possible at the very end. Thank you.
Okay. Thank you, Richard. And from what you say, I think that benchmarking still says that the need for benchmarking still says that these subjective factors are still at the center of the action. Subjective factors today as well are so important. Is that what you mean?
It really is, and by having that benchmark virtual vehicles, you're getting that definition of the correlation between the real world and your virtual world. So you have that continual reference, so you can compare your vehicle as a delta in the virtual world. But you've had your PALS profile, etc., which has said, okay, we need to be a little bit more sporty, half a rating up on response, a little bit down on comfort and what have you. You can do that with much more confidence in the virtual world if you have those physical vehicles, sorry, the virtual versions of the physical benchmark vehicles. It's the same as you would do it in a physical program. You would always try to keep a fixed reference vehicle to measure against, because things change, things move on, etc. This is just translating that into the virtual world, but also maintaining that link between the virtual world and the physical world.
Okay. Thank you so much, Richard. Very, very interesting. And now I would like to move from the UK to Spain, where we meet Guido Tosolin from Aplas IDIADA. Guido is a senior manager of chassis development and vehicle dynamics simulation. Hi, Guido. Thank you for being here with us. And I'm also interested in your point of view on this perspective, the zero prototype vision. What does it mean to you and to IDIADA, of course? And also my second question for you is, what do you expect from the driving simulators of the future in terms of new simulation opportunities, for instance?
Hi, Marco, thank you very much for the question. And well, of course, IDIADA is well known for our background in testing and validation. And this background has a very strong impact in the way we address CAE as well. So for us, it's very important that whatever we do on the virtual environment has an impact on the physical outcome that we get on the real product and the real vehicle. And this is why we understand that it's very important that the zero prototype vision can be realized only if the decisions which are taken on the virtual side are then aligned with what are the outcomes on the physical side. So that is really where the challenge is. So to make sure that every design decision which is made virtually can actually be aligned with what are the outcomes on the physical side. So the question is whether the driving simulator can actually improve our decision making on the virtual side. And so I think I'm very lucky because I had the chance to see already a few programs which have been supported by the driving simulator. And I think I can give a clear answer to that, which is yes, they can. And the big step they help you doing is the fact that on the driving simulator, you can see things which are very difficult to see on a diagram or on a KPI of a simulation realized offline. But it's not only that, but sometimes you can feel things that you hardly see in a diagram. It's also the fact that on the simulator, you will get an answer about whether that is a positive thing or a negative thing, and a better understanding of the trade-off between the attributes, because sometimes you can see one thing going up, another thing going down, and you don't know if that is overall better or worse, and especially moving in the direction that you want from that specific product. So this kind of refined analysis requires subjective evaluation. So the only way you can achieve that is through a simulator. So yes, the driving simulator will definitely be a key element moving towards the zero prototype vision. And the question then is, what do we need to exploit the full potential of a driving simulator in this process? So in the basic idea that we have is that you don't just need, like in offline simulations, to validate the vehicle model, you need to validate the driving experience at large. And so that means that you need to create the opportunity for drivers to do correlation exercises between the experience in the track and the experience on the driving simulator. And we in IDIADA have done this a few times now. And we support our customers to do that when they come to our simulators in their development processes. So this happens in a way where you have a physical vehicle that you can test on our tracks. You can test in specific situations on the real world. And then you get exactly the same model, which can be the previous generation model. It can be a benchmark vehicle. We have a database of models which are available, of which we can easily get the physical vehicles available also in the proving ground for the sessions. And the drivers can have this back-to-back driving experience. It's so important, this, because on the one hand, it helps the engineers, because they understand what aspects of the model need to be refined in order to improve the driving experience, in order to make the driver feel like he's driving something which is a good digital twin of the real vehicle. But this is even more important for the drivers to some extent, because drivers, they will need to understand how to interpret the feelings on the simulators, because they will never be exactly the same. And so this is a process they have to go through. And these experiences is the way they get to learn how to make this conversion from the driving simulator experience to the real world experience. And this sets sort of the baseline for judgment of the products they are developing. And it's a very interesting experience. Of course, this also helps us in understanding how to better do motion cueing settings, maybe take care of certain aspects of the cockpit, which are maybe deteriorating the driving experience, etc., etc., etc. So, talking a little bit, of course, we are doing this mostly using our digital proving ground. So that means that we have, with the support of VIA generated digital tracks of IDIADA that are already available, and you can use them in the simulator. And we even have some of the public roads around IDIADA, which is also very important, because you normally don't do tuning only on the proving ground. You do tuning a lot on public roads, and to have those roads also available is very important to make this this exercise. The second question you asked is sort of aligned with what was mentioned before by Massimo and Alfredo, because I think the future for us in the driving simulator, which is not really just the future, is actually quite the present for us, because we have been working on this for the last 2 years very intensively, is on the one hand, the ride comfort aspect, because it's nearly useless, so to say, to tune a vehicle just focusing on the handling aspects, because we know that we will always have to face a compromise in any tuning, and in the virtual environment it's just the same. So you need to tune the vehicle in a way which is good for handling, but it's also good for ride, and always the two things somehow will be one against the other. So if you just focus on one aspect, unless your product is very much oriented towards one performance area, then you will definitely end up with a setup that on the physical world will not work on the other aspect. So this is why for us, the ride comfort, of course, we can do handling very well, but this is why the ride comfort aspect is so important. And we are 100% sure that the simulator can be exceptional at doing this. To some extent, even better, because the motion cueing is much easier for ride comfort. But the difficult aspects are related with the vehicle model itself and with the motion platform, which has to be capable of providing a high range of frequencies. And of course, when we decided to go for the DIM 250, actually one big reason for us to move towards this platform is just how capable it is at representing realistic ride comfort, both for primary, for the motion envelope, but also for secondary, for the frequency response it guarantees, and in all directions, because comfort doesn't only happen in the vertical axis, it happens in the longitudinal, the roll, the pitching, etc. So we know that the potential is there, and we have been working on different concepts of how to improve vehicle models that are now used in the driving simulator so that they can be fully applicable also for the ride comfort. And that is a very important aspect. I think this is what we will see more and more in the future. And the second topic, I think it is active systems development, which again is not really the future, because to some extent is the present. We are doing a lot of work in active systems simulations in the simulator. And what we have seen is that that is an aspect you can work in a very agile way, also working just on compact simulators for, I would say, 80% of the time. And then you can use that base of work on the DIM to get the final refinements. And you can really save a lot of time, because again, even more than for traditional ride and handling, whatever it's done with active systems require a lot of subjective feedback. And the driving simulator definitely is a key tool for this kind of applications.
Okay. Thank you, Guido. Thanks a lot. Very interesting concepts. I'd like to ask you something, but I'm afraid I have to press on, because otherwise we might run out of time at the end of the session. Now I have a question for Boris Kirchner from GD. Boris has hi Boris, thank you for being here. Boris, you have extensive experience on simulators. You started at Porsche, then you joined Mercedes, and you are currently leading the vehicle dynamics team at GD. And I think this makes your point of view very interesting. So my question is, how does the concept of digital twin apply to the world of vehicle dynamics simulation, and what opportunities does it offer?
Yes, Marco. Yeah, digital twin is a very interesting one, and this is out as a buzzword since quite a long time. But actually, in the crazy situation of COVID, where we are in, we really value our digital twin models day by day. And I will give you some examples of it. Here at Geely, we are in a very agile environment. So Geely has become a very international company with development teams based in China, also in Sweden, in Gothenburg, in the UK, and now also in Frankfurt. And the whole company is set up to rely on this international environment, and we have an international supply base which is spread all around the world. And here the digital twin really now helps us to keep all the programs on track. We are doing a lot of innovative stuff now for Geely. Yeah, so we have a lot of innovations that we do the very first time, like 5-link axis, like air spring, active damping, active roll control, rear-wheel steering, all these active actuators in the chassis, which guarantee a great ride and handling performance. And I give you one example. We started a project a little bit than 1 year ago, where the idea was in the early phase, we use our multi-body simulation to, let's say, confirm the concept. And then we wanted to test that concept on the VI grade simulator in Gothenburg of Geely at our SEFT colleagues. And that was exactly in April last year. And COVID stopped us from traveling to Gothenburg. And the concept was later on to build a mule car based on that experience. That mule car was actually built on China. And so Geely has a great park of all measurement equipment in China and proving grounds, bench tests, but the subjective ride and handling engineers of Geely, the real experts, it's in Europe. and we were not able to travel and tune that mule vehicle there. And end of last year, we started to build up the first engineering prototypes also in China. We have never driven that vehicle, but the experience we made with the digital twin, because then we put a high effort in the correlation of our digital model, it helped us to progress with this program. And now we have prototype vehicles around the world, and we see a very high correlation between our digital models and the prototypes, and it really helps us to identify issues and problems we see in China. We can directly see in the model here. We feel the same in the model, and it's awesome, that experience. I've never thought a digital twin could give you this, but till now we could really keep all the gateways and milestones in the chassis development of that program. And another good example is the seamless integration of our supply base. So we use our VI gray models, our vehicle models, compile them as a black box models, send them to our suppliers, and they do the component optimization, and they do their control systems tuning with our black box vehicle models, and then they send us back their black box controller models. We integrated and tested them in our digital twin. This gives us now a great advantage, and maybe we all know this. We're making BEV vehicles, new BEV vehicles with all that complex active systems in there. And honestly, whenever you begin with a mechatronic system, the maturity level is really low. Yeah, and you face the systems are not talking to each other. The BEV vehicles, they are not charging, you cannot put them into gear, and you have a lot of vehicle downtime in the beginning. And whenever we face a problem where we wanted to test something, but we cannot test because of the vehicle maturity, we now can just move that test to our digital twin. And we continue the test in the digital twin, and our subjective engineers, it's like the real car is not running, so they jump to the virtual one. Yeah, and this is a very interesting concept. The next is we try to move that we call it from push to pull. So what we want to make is that if one slight parameter changes, we build up our digital twin that it then automatically calculates all the KPIs and give us all the attributes we need to recheck on the virtual vehicles as a preview. And this, I think, fits very good what Richard explained also about also attribute balancing, and how Guido explains how he uses a simulator to give a preview on the active systems. And it's the same experience we have here at Geely for all our programs.
Okay, very, very interesting. We can really say that the simulator is a cooperative environment. Really, this is your example is just a demonstration for this. And yeah. Boris, I planned one more question for you, but I'm afraid I will keep it for the end of the session if we've got time. And now to my friend Giuseppe Di Rosa at Lamborghini Automobili. With Giuseppe, we've known each other for a long time, and he manages all the vehicle dynamics models across the entire product range at Lamborghini. Hi, Giuseppe. And my question for you is, I believe that sports car design is becoming more and more challenging because emotional aspects and perception, which are so important for a sports car, somehow can collide with increasing complexity in the automotive world. And I'm very interested in this subjective thing, subjective evaluation and attributes assessment, perception, and so on. And what's the role that the simulator plays in this scenario, which is very peculiar for a sports car?
Well, some bits have been already answered during the other sessions of my colleagues, and I'm trying to put all the bits together. Maybe I'm very happy to have here some suppliers, some test tracks, and some other OEMs, because we more or less share the same issues and topics. So it is very interesting. Well, yeah, the complexity is increasing, absolutely. I want to give a few examples in our small company. One big complexity is for sure decreasing the time to market. So from scratch to the start of production, this time to market has to be squeezed in the past years. If you look at our company history, we have always had very long life cycles for our cars. Nowadays, the market is asking us something different. And this means that we have to condense, to reduce this development time. Well, another complexity, it is the product complexity itself. Our CEO at the beginning of the week made public our roadmap for the next 10 years. And we will have a lot of hybrid models and something more, as you've heard. Being such a small company for such a complex product is a very challenging moment. It is a moment of transition, very, very difficult to handle, and in physical term and also in virtual term. I'm speaking about obviously the powertrain, so electrification and hybridization of the powertrain, but also on the homologation of the components of the work car. And these obviously collide, as you said, with the emotional aspect. Just to think about how emotional are our cars in terms of performances, sound, vibration, noise, and what this will be in, well, 10 years' time with electric vehicles or electric driving modes. And this is something that we still don't know physically because we have to design this. And so this is where exactly simulation, so desktop simulation, but also driving simulators take a big part on the game. We don't have to forget the offline simulation, which sometimes we just forget where we come from. All of us comes from desktop simulation. Then only on the later years, we had the possibility and the millionaire budgets from our finance offices to buy these big driving simulators, very expensive holy grails. So when we had the possibility to test physical, physical track and virtual at the driving simulator models or prototypes, we then ended into divergence. So from the subjective evaluation and the objective evaluation. And we all know, and Richard said this very clearly, and how this is complex, and it is a cultural issue as well, because obviously we all come from these two poles, you know, so numbers, only numbers, is just numbers and graphs, as Guido mentioned, and some components of our teams are only subjective, just feelings and just touching the components or the car itself. And this is the big complexity in these days. And this is the only way, the driving simulator is the only way we can find a connection between the virtual and the real, the physical cars. In our company, this has been a cultural shift, and this will be a major cultural shift in the futures as well, mainly dedicated to specific topics, as I mentioned before. So probably powertrain would be one of the most complex topics to handle. About subjective evaluation, we work pretty closely as we work at the test track. We have standardized methodologies and maneuvers that we replicate at the driving simulator as well at the test track. And this point, it is very important because this explains a specific request that OEMs makes versus the suppliers of the driving simulators. We need very precise virtual environment, because we work in the virtual model region. But if we don't have, from the other side, a perfect virtual environment, we fail completely. I'm speaking about, for example, precise laser scans for test tracks that are mandatory, for example, for tire testings. We need very specific sound model. For example, when we're speaking about transition from electric to IC functioning, this is not an easy moment, as you can imagine. I'm speaking about traffic or graphical environments in, for example, ADAS testing, or well, simply reference point in a racetrack that are very important, as we as a race engineer knows. So this is the other connection, and what have been said before by the guy from the tire manufacturers. So this sort of network between and the exchange method between suppliers, OEMs, and then virtual environment suppliers. This is absolutely very important. Getting back to the test that we do, and sometimes, for example, we perform strange tests that we cannot perform in a real environment in a very early phase of prototyping, for example. Maybe we need to do some dangerous tests or very high-speed tests. Maybe the prototype at the beginning in the beginning phase are not capable to do this in a safe way. So we can do this way before the physical cars are out of the track. And in this term, obviously, we're working a lot with driving simulator as a validator of methodology. We perform and we design methodology, testing methodologies that are going to be later on development phase, being testing on the physical cars, but we do this first at the driving simulator. Because we want...
Giuseppe, I'm afraid I have to press on because
it's fine.
I have to stop the session at 5. Yeah, sorry, I'm very sorry about that.
The connection, yeah, it's fine.
I'm very sorry because we have just 8 minutes left, and I have a question for Konstantin Sedlan from Volkswagen. Hi, Konstantin. You are in charge of virtual process development for vehicle dynamics, and when we exchanged a few mails prior to this session, you mentioned that Volkswagen in the inclusion of a dynamic simulator within this process. And I guess this process is very challenging at the moment with the transition to electric vehicles. And so I'm asking, what are your expectations in terms of potential benefits with the simulator? And how is it going to change the interaction within the departments involved in this R&D process at Volkswagen?
Yes, okay. First of all, I would like to say that I'm very glad to join this roundtable today. Thank you for the invitation. And regarding the time, I will try to give you a short answer on your question. So, yes, you're right, Marco. We are investigating the application of a simulator. But to make it clear, at the moment, at Volkswagen, we do not have and we do not use a simulator for our development activities, but we have, or there is a kind of a pre-development project with several departments involved to evaluate this technology, the capability of the simulator for our development activities. And this process is still ongoing. And our general goal is to have a further improvement of the development process regarding chassis tuning, chassis development, tuning of several chassis components, and it is for us, let's say, a kind of a next logical step, because we have already the virtual development implemented in our processes. We had good success in the past, especially with our tire suppliers and regarding virtual tire development. And now this is the next step, of course, to get or to take the driver in the loop and to enable the subjective assessment of the vehicle dynamics with a simulator, and to provide the testing driver with a subjective impression, yes, or a driving impression. So this is, of course, a great advantage, and to keep the surrounding conditions constant. So this is also very important for us. And yes, as I said, the process is still ongoing, and we gather experience on that. But right now we are quite confident that we will get good results, especially in the linear range, in the linear vehicle dynamics range, for some tasks, for chassis tuning, for example, steering system tuning, and we are confident that it will work. What might be challenging is to extend it to higher accelerations, to limit conditions, and we think that we should spend much work on that. What I would like to mention, and I agree fully with Massimo and what Alfredo said at the beginning, that it is very important to have accurate simulation models. And of course, the simulator is only as good as the simulation model which is running on it. And there currently are no standards and no standard requirements regarding this models, and it would be a great idea to work together on this topic in the future to get some improvement on this. And this is also touching one of your questions. How is the way of collaboration changing in the future? It is changing a lot, so that we need the models, the exchange of models, to also with the suppliers. And in the past, there used to be an exchange of hardware, for example, with the tire manufacturer, hardware, tires. And now we have to exchange models, vehicle and tire models, for example. And this is also challenging because we do not have some kind of standardization. And that would be great to work on it in the future.
Okay. Thank you, Konstantin. Thanks a lot. We have just a couple of minutes for Giuseppe Raimondi from Maserati. Giuseppe, you have an impressive facility at Maserati, the Maserati Innovation Lab. Can you tell us something about a case study where this Innovation Lab has been fully exploited?
Ciao Marco, hello to everyone. First of all, thank you for the invitation to this virtual roundtable. Yes, simulators are the core of the Innovation Lab in Modena, and of course you can understand how the use of these advanced tools can change the conventional way normally used for a car development. In our lab in Modena, we have two simulators that we use for not only for vehicle dynamics, but to develop a lot of activities. We have a static one and a dynamic. The simulation, with the simulator, we in the first time, in the first part of the development, we have the possibility to put in the loop not only the driver but also several bench in simulation. You can understand the number of benefits that we have working in this way. But we moved on. We create a new approach that we call virtual vehicle dynamics. With this approach, we pass from a lot of physical tests to virtual tests. We create a virtual car that is a model in which all the engineer that works on Innovation Lab can put all the studies and all the development. So all together we focus on our goal and working together in order to extremize the performance of our cars. Now I want just to spend 2 words about sharing my experience with on the development of the MC20. For the first time, we use this type of approach to develop a new car, it's the MC20. So after a huge work of correlation and a lot of activities, of course, because we need to align all the model, we create our link with the reality. So in this way, the expert drivers was able to recognize the feedback on the driving simulator as an equivalent feeling perceived during a test on a track. So we create our wheels proving ground, also described yesterday by Giovanni Boreanas in the conference, and we start with the development. So we start from suspension design. We pass from to test all the hardware, so springs and stiffness, car balance, and also we work on the active system calibration, that are internal development in the innovation lab. We work a lot on tire performances, as described by Alfredo also before, in order to maximize the grip, increasing the agility of the car, and also to maximize the steering feeling and the fun to drive aspect of the car. We test a number like 500 variants, and we traveled on simulator more than 10,000 kilometers. So the simulator decreasing the number of physical tests. So just concluding, driving simulator not only decrease the development time, but increase, first of all, the quality of the result.
Excellent. Thanks a lot, Giuseppe. Thank you, everybody. We are a bit behind schedule. I'm very sorry to stop here. Sorry, Giuseppe, to stop you just before.
Problem.
And yeah, see you in the next session, maybe. Thanks a lot, guys.